Good day to all. Today we can discuss about what is a histogram in the subject foundations of data science. So what is a histogram? A histogram is one of the most fundamental tools in exploratory data analysis. It provides a visual summary of how much numerical data is distributed across a range of values. So unlike bar chart, it can compare categories. Histogram reveals the underlying shape of continuous data also. So histogram displays the frequency or count of values within consecutive equal width intervals called bins. So this bins is the major one in histogram. So bins are the building blocks, we can say. The entire range of data is divided into non-overlapping equal bits. Each bin represents a values on the x-axis. And the bin, for example, 155 to 160 means capture all women who, for example, if you are taking a woman's height, all will be coming under this height greater than or equal to 155 and less than 160 centimeter will be coming under this bin. So bin width is calculated by maximum minus minimum by number of bins. The bin width determines how much data is aggregated into each bar. And the second thing it needed is counts or frequency. The height of each bar in a histogram tells you how many data points fall within that bins range. So now each bar height represents number of data points. So higher bar represents more values in that range. Shorter bar represents fewer values in that range. So based on the density, so it is sensing density, how much amount there, how much count is there, are true to show proportion instead of count. And then just how to choose the bit count. If you are choosing the bin count, but too few bins means it hides details under smooth pattern, we can say. Too many bins means noisy, hard to see pattern like that. So normally we are going to choose as is default bins is integer of root of n. So number of data that integer root is calculated. So the rule of thumb is considered to be 10 to 30 bins work well for most data sets. So choosing the right bin count requires balancing detail with clarity if it often iterative. So what are the things we have to look for while considering a histogram means once a histogram is plotted, examine it with the following features. Where is the bulk of the data center? That is actually related to mean and median. Okay. The second thing is a spread. How wide is the distribution? A wide spread means high variability in the data. Then what should be the shape? Is the distribution symmetric? Or does it one-sided, that is skewed? Or it is peaks, unimodal or bimodal? So like that, all those concepts you should look whenever you are going to look for a histogram. And the typically the distribution shapes with four categories we are seeing. So the shape of the histogram is one of the most informative feature of the data set. It is actually how values are spread that where exact values lies and what statistical measures are most appropriate to use. All those will be so first is bell shape, that is the normal curve. Or we can say it is the most famous and widely used one. Perfectly symmetric around the center means skewness is zero, mean equal to median equal to mode. For example, it is taken for a height of 160 centimeters. Center one is having the huge value. The right and left sides are mirror images of each other. So we can use the statistical tools like z-score, standard deviation, t-test whenever you are going for normally distribution. Okay. And the second one is we are going to take an example with household income, property prices, then viral content shares or wait times, all these coming under right skewed as positive. A right skew distribution has a long tail extending towards the right higher values. The bulk of data clusters on the left. So skewness G is greater than 0, mean is greater than median, and the distribution leans left with the rightward tail. Mean is pulled upward by extreme high values, outliers on the right. And best measure of center is median. It is resistant to outliers. So log transformation is often applied to normalize right skewed data. Next is left skewed data. In this left skewed data, example, we can exam scores in easy test, age at retirement, then product lifetimes near end life, all will be coming under left skewed. So left skewed distribution has a long tail extending towards the left lower values. Most values are high with the few very low ones. So skewness is less than 0. That means the distribution leans right with the leftward tail. Mean is less than median. So in exam score data, most students score high, but a few students score very low. That is actually a typical example for left skewed or the negative data. Best measure is median here also. Then is bimodal distribution. See that there are like two distributions: pedestrian traffic, morning and evening peaks. In the noon, you will be having lower traffic, so it will be declining. So heights of mixed male and female population, it will be different in the years, right? So it suggests the data will be coming under two subgroups of data. So like considering splitting. So neither mean nor median may represent either group well. Recommended action is split the data into two groups and analyze them separately. That will be the example for bimodal distribution. So how to plot a histogram is an example. A Python code is given. We have key parameters considered is bins is 20, density should be true, edge color, border color between bars represents a range as A, B between the range. Cumulative value is true, historical type is step, outline only, no fill. It represents alpha is 0.5, label name. So first is import libraries. The first two line represents the libraries. NumPy is used to generate and handle numerical data. This matplot library's pyplot module provides the histogram functioning for plotting. And second one is the three lines represents creating a sample data. So np.random.speed of 42 ensures reproducibility. The same random data is generated every time. Height simulates a normal distributed data set with a mean value of 160.14 centimeter and the standard deviation of 7.06 and the n value as 4221 number. So income simulates a right skew distribution using an exponential distribution. That's the first three, second setup. Next is you are going to plot the basic count histogram. So the figure size is of 12 of 4 and represents height as well as the count. You are going to plot the height of woman. And the next is density of histogram. How the density, it is based on the bin count. So setting density is true, changes the y-axis from raw count to probability density. The total area of all bars must be 1. So this is essential when comparing the distribution of different samples. This is one example for plotting the histogram. So hope you have understand. Thank you.